If you've dabbled in electronics, you've probably thought about making your own printed circuit boards. PCBs are more robust, more compact, allow for greater complexity, and are easier to assemble than any other prototyping method. Perhaps you've made a few circuits already using protoboard, VeraBoard, or a breadboard. These are great for temporary assemblies, but if you want something more permanent, it may be worth your time to make a printed circuit board. We'll make our circuit using a blank copper board, a mask, and an etchant solution. This is a Phenolic resin board, which is both easier to work with and cheaper than the FR4 fiberglass alternative. And this is anhydrous ferric chloride, which is a metal salt made of iron and chlorine. You can also use muriatic acid, or if you're very patient, salt, vinegar, and a 9-volt battery. Nonetheless, ferric chloride remains the most common etchant for DIY PCBs. We begin by printing out our circuit in reverse using a laser printer on some glossy paper. Today I'm using the Reboot 2.5 delay from tonepad.com. Once it's cut down to size, we clean our bare board using some high-purity isopropyl alcohol. Now we take care to protect our work surface and heat up a regular clothing iron to somewhere between 125 and 150 degrees Celsius. You can use it to preheat the board by setting it on top. Once the board is fairly hot, we can very carefully apply our toner mask. It should stick to the copper surface. Now we heat up the toner mask so it begins to fuse. You can use the tip of the iron to go all over the surface of the mask and make sure that it has stuck. This part takes a while, so be patient. You'll know it's ready when you can see the circuit faintly through the paper. Once it's all fused, go ahead and soak it in some water. You can use an X-Acto knife to cut some grooves into the paper and let it soak through more evenly. Once the paper is practically translucent, it's time to start peeling it off. The toner underneath is pretty delicate, so be sure to be very careful peeling it off. This stage, again, might take a little while, so be patient. You can use a toothbrush and some soapy water to help you get the finer details like the center of the via holes and in between narrow traces. Once you're all done, you should have a nice clean toner mask with bright copper in between. The toner is black, but it looks white because of the paper backing that's adhered to it. If you have any gaps in the mask, you can go ahead and fill them in now using a Sharpie or nail polish for larger areas. I'm going to fill in this area here so that we don't waste toner on a big spot we don't need. Now we're ready to etch. Prepare your solution, protect your hands, and pour enough of the etchant to cover the bottom of a plastic tray that's bigger than your PCB. Now gently drop your PCB into the solution and agitate the container so that you get nice clean coverage over the whole surface. You should begin to notice a pretty immediate color change in the uncovered areas of the board, although it'll take a little bit longer for the entire surface to get etched through. If you're not sure if it's done yet, you can take it out and hold it up to a light. Completely etched areas will be basically transparent, while areas with copper remaining will still be opaque. You can accelerate the process by using a sponge or a toothbrush to apply the etchant and then brush away the copper chloride that precipitates. When it's all done, your circuit will be practically transparent. Notice how the parts under the nail polish are still nice and shiny, although it looks like I missed a few spots there. At this point, we could remove the toner mask using acetone, but it's a good idea to leave it on to protect the traces for the next steps. Now is a good time to trim your board down to size using a rotary tool or a handsaw or your power tool of choice. I don't really recommend the Dremel, to be honest, because it kicks up so much dust. This next step is optional, but if you have a parts mask for your PCB, it can help a lot during assembly. Print it out on the same paper, and then drill some index holes in matching spots on both the mask and the PCB to help you line it up for the transfer. Now we tape it down and use the same method we did before with the iron to apply even pressure to the whole board and transfer the toner. The thermoset plastic in the toner adheres a lot more easily to the copper side of the board, so you might have to be more patient and a little bit more gentle with this part of the process. Again, some soapy water and a toothbrush can help. You can see I was a little bit aggressive removing the paper, but you can read all these resistor values, which will help a lot, and I can fill in the rest of the parts with some Sharpie and a ruler. This step is really just to help with assembly and to make repairs easier down the line. Now we're ready to drill the board. Remember earlier when I told you that working with phenolic resin is a lot easier? Well, that's because you can use these regular high-speed steel bits. If you have a fiberglass board, you're going to need to use tungsten carbide bits, which are a lot more stiff, and if you hold them in a hand drill, you're very likely to break them, so you'll need a big drill press. Phenolic resin is easy to drill using just a regular hand drill or a Dremel tool like I've got here. Although it does help a lot if you have good clamping. The copper around each of the via holes will actually guide the drill bit into the center, so you don't need to be that precise when you're lining up your cuts. Just let the drill do the work for you and be patient. It's easy to miss one or two holes during this stage because there's a lot of them, so it's helpful to have a pin vise around so that you can fix it later without having to set up the drill again. Now for the best part. We get to remove the mask and reveal the beautiful circuit underneath. Apply some acetone or nail polish remover to a paper towel or a piece of cotton, and gently scrub the surface of the circuit, making sure to protect the surface underneath. The plastic toner will come off easily, revealing the clean copper surface below. Take a moment to admire your handiwork before you reach for the soldering iron. Now that our board is etched and drilled, it's ready to assemble. If you're not going to put it together right away, it's a good idea to tin the traces, using either a tin plate solution or a soldering iron to apply a thin layer of solder to each of the traces. This will make it easier to solder later and prevent the copper from oxidizing. If you enjoyed this video and would like to see more like it, consider subscribing and leave me a comment to let me know what else you'd like to see. Thanks for watching. See you next time.